All right, number 11. So the following circuit has a current of 0.1 amps. Find the resistance of the mystery resistor. Hint, find the voltage across the 5 ohm resistor using V equals IR and use that to help you. So I have two different resistors here. I'm going to call this one 1. I'm going to call the mystery one 2. So here are my known values for 1. Here are my known values for 2. The only values that I can have, the only values that are possible are V, I.
Can you move it down a little bit?
I sure can. Ooh. Snap.
Wait, so you don't click it on the actual projector?
No, I can actually, I can use the mouse button. I know. So I'm going to write V equals IR for each of these. And I'm going to write in the numbers that I know. So first of all, this one has a resistance of 5 ohms. It literally says that. This one has a resistance of question mark. And that's all. Woohoo! It's going to turn out great. In order to figure out the rest of this, I need to use these things. Okay, first one. I is constant for everything in series. Or I is split for things in parallel. So I look at this and I say, okay, is this a series or a parallel circuit? Well, they're all connected together. There's no multiple paths. There's only one path. Everything is connected together. That means everything has the same current. That's 0.1 there. This is 0.1 here. This is 0.1 here. Every single place, the current is 0.1. So I'm going to, right off the bat, without doing anything else, immediately write I is 0.1. And I is 0.1. Look at that. The reason why we talked about 7 through 10 is they're going to make solving problems a lot easier. I can look at this and immediately say, oh, it's series. They all got the same current. And then I'll write it down. That's it. I don't have to do any math. Just write it down. So then I gave you the hint. It said, find the voltage for the 5 ohm resistor using V equals IR. Well, look, we got R. We got I. We can solve for V. So I'm going to go ahead and do that. V equals IR. So the voltage is what I'm solving for. I is 0.1. R is 5. Gives me a voltage of 0.5. Questions so far? Okay. All right. Yes?
Well, so on the left of it, it says 1.5 V. What's that for?
That's the voltage of the battery. That's just the value of voltage the battery has.
Oh, okay.
Which is going to be really helpful now. Okay. Now, you can see all I need to do to find R here is do V equals IR again. V equals I times R. So I need to figure out what V is here. So let's look up here again. We had a discussion about voltage. We said that voltage is constant for things in parallel, but for things in series, they have to share the voltage. Okay, so I go down here and I ask myself, I say, self, is this parallel? No, it's not. So that means they don't have the same voltage. They have to share it. Okay, well, how much voltage do they each get? The first one got 0.5 volts. So how much total voltage was available? How much money did Mr. Moneybags Mr. B have to give to his kiddos? He had 1.5 volts of energy. So if this light bulb gets 0.5, how much is left over for the other one? 1. To do it a little bit more mathematically, we're going to find the potential difference. So the potential difference at the start of the battery is always the value of the battery. So the voltage here, 1.5. If this has a voltage of 0.5, that means this is the difference from the left to the right. So if it was 1.5 and there's a difference of 0.5, then the leftover value now is 1. Okay? This has to have a difference between here and here. This is connected to the battery, and the other side of the battery is always 0. So what's the difference between 1 and 0? 1. Okay? There you go. We will do some more problems like this. Okay? We'll do some more problems like this. But I like to kind of play around with them. I wanted to kind of show you what it looks like first. And then we'll get into more of them later. But I just kind of wanted to kind of tease your brain.